Video we're going to go over how a photoresistor like this gets light that comes into it. Light comes into it. It then sends out a voltage through one of its leads to the Arduino, and then the Arduino is going to take that voltage and decide to send a signal, another voltage, to this indicator here. Okay, and light this indicator according to how much light this photoresistor receives. Okay, so how does this work? Okay, first let's start with this schematic. Okay, we have a battery with a positive, negative. Okay, here's the photoresistor symbol with two arrows pointing at it, representing light. Okay, so what happens is this battery sends out a charge to the photoresistor, and then it goes down to the resistor, and then it goes back to the battery. Same as usual. Like this last schematic we had earlier, we had positive, go through a resistor, goes through this resistor, and back to the battery. By the way, the photoresistor is a resistor. Okay, it's a special resistor. This resistor, when sunlight hits it, or any light, not just sunlight, could be any light, a flashlight, when light hits it, its resistance goes down. It drops its resistance. That makes the current increase because the resistance to the current goes down. As that increases, it goes across this resistor and makes a voltage. Okay? Right here we have current goes across two resistors. Current across a resistor times the resistance of the resistors equals the voltage. Okay? So as this current increases, current increase times the resistor makes the voltage increase. Okay? So that's going to make this here increase. We're going to tap off of right here and find that increase in voltage and send it to the Arduino. Okay, here we have the Arduino, and we see how it's really wired. Okay, we have 5 volts wired to the photoresistor, then through a resistor down to ground. Okay, as light hits the photoresistor, the current goes up, causing more voltage here. Okay, there's always voltage here, but as the resistance goes down, the current goes up, causing more voltage here. We're going to tap off of that lead right there and go send it to the Arduino at pin A5. Okay, then the Arduino way over here at digital pin 11 is going to send a signal to the indicator, as this symbol shows with light going out of it. And it's going to cause the indicator to light up, sending light out. And then this voltage goes to the ground here. Okay? So, let's go over the programming. Okay, we don't need any other code, so we're going to comment this out, comment out the include. Okay, next we're going to do integer photo R pin 5. Just a heads up, photo R pin means photoresistor pin right here. Okay, we're going to tap off of the photoresistor pin. Okay, and that's going to be 5. We're going to do analog 5. I'll tell you later why we're going to do analog. Okay, then integer LED pin assigned the value of 11. Okay, this pin 11 here we're going to use because it's connected to the LED. Okay. And then integer value assigned the value of 0. We're going to initialize the variable value to 0. Initial value will be 0. Void setup parentheses, open squarely, pin mode. Okay, that's what it says, pin mode. LED pin, that's pin 11. Okay, shall be set to output, outputting out of pin 11. Serial.begin parentheses 9600. Serial means we're going to set up a serial connection between your Arduino and your computer program Actually, it has a screen called Serial Monitor. Okay, it's located under Tools. You click on Tools, and then you go to Serial Monitor, and it'll show you, it'll pull up a screen. Okay, so that's what we're going to do. Serial.begin, begin, 9600, that's the baud rate. That's how fast there's going to be communication with it. Close squarely. Void loop parentheses. Okay, we're going to do void loop. We're going to do loop because we want this to continuously be running. We don't want it to run up one or twice. We want it to constantly be running. So that we're going to use loop. Open squarely. Value is assigned the value of analog read parentheses photo R pin. Okay, photo R pin is assigned the value of 5. So we're going to look for a 5, but because it's analog read, we're going to go to A5, not any other 5. So photo R pin 5. We're going to analog read A5. And we're going to have value is assigned the value of analog read photo R pin. So whatever value is on A5 is going to be stored in the variable value. Next, we're going to do serial.println parentheses value. Okay, what we did here was set up a serial connection with your serial monitor. Okay, this is where we're going to use it. Serial.println value means we're going to print on that screen the value stored in value. Okay, whatever was stored in value. Okay, we're going to print it on the screen. ln means new line. Okay, go to the next line. Okay, so we're going to keep doing that. Every time we receive something on pin A5, we're going to print it. And then go to the next line and print that one. Okay, analog write, parenthesis, LED pin. LED pin is 11 here, comma value. Okay, we're going to print the value of LED pin. To LED pin. Okay, we're going to print the value of value, which was stored in value. Okay, analog write. Okay, now even though we're on pin 11 of digital side, we're going to be using analog. How can we do that? Well, as you notice on your Arduino, some of your pins over here next to digital have a little wave on it. That means that it's special. It's capable of doing pulse width modulation. Okay, remember digital is just zeros and ones, and analog is fluidic. Everything, it's everything from 0 to 255. Now, what we want to do with pin 11 is vary the width of that digital signal. Okay, thus pulse width modulation. Modulation means change. Okay, we're going to vary that width, and thus we could get kind of a fluidic type of range of signals, like 0 to 255, by how much its width of the signal is, instead of just the bottom and top. Okay, so we're going to analog write LED pin 11, the value it read at pin A5. Then we're going to delay. Okay, so that signal out of 11 goes through the indicator, sends out light represented by these two arrows going out into ground. Okay, so that's basically how the Arduino works as far as the photoresistor goes. Thus we can have light, more light comes to photoresistor, means more light going to come out of the indicator. So if the photoresistor is in a room we don't know, we're going to be able to find out how much light is in that room by looking at the indicator. So that's it. I'll see you next time.